All right, guys. For lesson 1.5.1, we're talking about literal equations, which basically just means solving for the indicated variable. You're going to have to really have a good core foundation of order of operations. But if you have that, these are really not that bad, especially the examples I have here. So I'm going to go through these pretty fast. So if you need to pause the video and copy down what I'm doing, please do, because I'm going to roll right through 3 or 4 examples here. So we want to solve 6y minus 12x equals 18 for y. In other words, get y by itself. That's what that means. Okay? So this is where terms and coefficients and all that stuff that we talked about, and factors especially, that we talked about before, come back. All right, so what I have here is I have 6y minus 12x equals 18. Now, order of operations says I can't get that y by itself unless it's the single term on that side by itself. So I need to move any of the other terms away from it. The other term that's attached to it is this 12x. Okay, and that's gonna make a little division. I don't want to do that. So right now it's a minus 12x, right? Subtracted. That's how it's connected. That's how that whole term right there is connected to the 6y. So to move that, we need to add 12x to both sides. Now, you'll see me do this a lot, so don't freak out. I'm just basically keeping everything lined up by doing this. So minus 12x plus 12x goes to 0. Okay, that leaves 6y. Now on the other side, these are not like terms. The 18 does not have an x, therefore they cannot be combined. So we're going to rewrite it as an addition problem. 12x plus 18. It's traditional or standard form, if you will, to write the x term, right? This term out in front of the constant. If you'd have put 18 plus 12x, that's not wrong. It's okay. I try to write it the way it's supposed to be, or the way you're most likely to see it. And if you see it the other way, that's okay too. All right, so now I still want to get y by itself, and it's currently not. So the 6 is connected, but how is it connected? Right? Those are factors, aren't they? It's 6 times y. So if I want to undo that, I need to divide. Since I divided this whole side by 6, I need to divide this whole side by 6. Okay? And technically, I say technically, and you'll see why in a second. Technically, that is your answer. Technically, you have solved for y. The only problem with that is this over here can definitely be simplified, right? So back in middle school, you learned a rule that said if you're dividing by a number, you can divide, or if you're dividing a sum or a difference, kind of like distributive property, you can multiply something by a sum or a difference. You can also divide by that sum by a number, right? So it's kind of like distributive property. You can think about it like this. That's 1/6 times 12x plus 18, right? Or you can just think about dividing the 6 into both parts. It's the same thing either way. So if I do it as a distributive property and do that, 1/6 times 12 is 2x, and then 1/6 times 18 is 3. So 2x plus 3 is fully simplified. So y equals 2x plus 3. All right, moving on. Feel free to pause if you needed to copy that down. All right, same thing here. We're going to solve for y. So 15x minus 5y equals 25. So first thing I'm going to do, I want to keep the y term. Okay, so I need to move the other term. Now, out in front of that term is positive, right? So to undo, it's still addition and subtraction here. But to undo this positive term, I'm going to need to subtract it because I want it to go to 0. Okay, the term that you are moving, you want to do the inverse of that. So the inverse of addition is subtraction. So minus 15x over here. Those go to 0. The minus in front of the 5 comes down as a negative. Okay, so negative 5y now. And then we've got negative 15x plus 25. You could also have written it as 25 minus 15x. It goes back to the same thing I was just talking about trying to put the x term first. All right, now, same as the last problem, we want to divide, but this time we want to divide, make sure we divide by the negative 5. Okay, and the reason we do that is to make sure that goes to 1, which leaves me just with y. Okay, now, I'm going to skip the steps of showing it as the distributive property that we did last time. You can go back to the first example for that. I'm just simply going to divide the 5 into both parts, the negative 5, excuse me. All right, so when I do that, negative 15 divided by negative 5 is 3. The x comes with it. 25 divided by negative 5 is going to make that become a minus, and that's going to be 5, right? Because it's negative 5, so minus 5. So final answer here, y equals 3x minus 5. All right, we're going to do one more example in this video, and then the last 2 examples will be their own separate video. All right, so we're doing the same thing here. 4y plus 3x equals 16. Okay, solving this for y. So again, the term that doesn't contain the y needs to go away first. All right, gone. So now I've got 4y equals negative 3x plus 16. Next step, undo that factor. So divide by 4. And you get y equals, now this time it doesn't divide evenly, or at least part of it doesn't. The 3 and the 4 don't simplify to a nice neat whole number. But if I did 16 divided by 4, it would. So I still want to split this up, right? I still want to take the 4 into each part. But how do I do that? Well, since this one doesn't simplify, we just leave it as a fraction. Okay? You want to simplify what you can. And then 16 divided by 4 is going to go to a nice neat whole number of 4. So y-intercept, slope, all that good stuff gets tied back in. You could then graph this pretty easily. Negative 3 over 4, down 4, right 4. Or you could go up 3, left 4, right? Your negative slope. But that's solved for y, which is what we were asked to do. All right, and that will do it for the first 3 examples. The next 2 are going to talk about how to do this when you just have formulas, okay? Feel free to go back and rewatch if you need help or ask me.